Hello, welcome back. Today we're going to look at the arc length of a circle. So um, in this lesson we'll also have an introduction to what a radian is. So let's draw a couple circles here. All right. So we can have a central angle in terms of degrees or radians. So if we have degrees, so we'll put degrees on the left and we'll have radians on the right. It's important to realize that the measurement of the angles is the same, but they're in different units. So it's just like when you're measuring something in inches versus meters, that kind of thing. The length is still the same, but it's just different types of units. So degrees we're familiar with. They're 360 degrees in a circle. And there are about 2 pi radians in a circle as well. So it's still the same circle, but one's in degrees, one's in radians. So let's talk about radians a little bit now. So when we have radians, we have to worry about r, and the arc length is also going to be that distance r. And so here's a definition of a radian. A radian is equal to the measure of a central angle that intercepts an arc with length equal to the radius. Okay, so if we have our circle again, what that's saying is, this is not drawn to scale, but the central angle, theta, theta is just the variable for angles, especially when we're dealing with radians. Theta is used a lot. That theta is equal to that arc length of r. So we have the same length of r. If we wrapped it along the circle, it'll stretch out and be formed by that angle. So a radian is just equal to that central angle, theta, where if it makes the arc length of r. And this would be 1 radian here. And if you stretch the length r around the circle, it'll go around about approximately a little over 6 times. So that's, of course, this is not drawn to scale. But there's 6.2 radians that will go around the circle. So I got 1, 2, 3, 4, 5, 6. Yeah, it's pretty close. So, and when you transfer that to in terms of pi, so you can also say that 6.3 radians is about 2 pi radians, approximately, because pi is 3.14, and 2 times 3.14 is about 6.28, which is really close to 6.3 radians. So that's why we say that there's 2 pi radians in a circle there. So we can convert degrees to radians and radians to degrees very easily. So if I have 45 degrees and I want to turn it to radians, all I have to do is multiply it by pi over 180. Okay, and so we can cross cancel some terms here. And eventually we'll get 4 on the bottom. So 45 degrees is the same thing as pi over 4 radians. And if we want to go from radians to degrees, we just flip the ratio. So if I have pi over 3 radians and I want to go to degrees, I multiply that by 180 over pi. And if you notice here, the reason why you multiply by 180 over pi is the pi's will cancel. And you get 180 over 3, which is just going to be 60 degrees. So pi over 3 radians is the same thing as 60 degrees. So that was a little introduction on radians. In the next video, we're going to see how to use 2 different formulas to find arc length, one in degrees, one in radians. So now we have a little bit of idea of what a radian is. And I encourage you to research some more videos online about radians. There's some good visuals out there that will give you another understanding as well.